This session is about building a native multi-platform SDKMAN within JavaFX. So what I've done is wrapped SDKMAN into a nice UI that actually runs on every operating system that's useful to have such a tool. Links to the slides are at the end, so there will be a QR code at the end that you can scan and find these slides. So first off, show of hands, who is using SDKMAN? All right, half of the room, okay. Who is using Windows? A bit of the other half, but it's usually the split between that. The ones that are using SDKMAN are not on Windows and, well, vice versa. But for those who do not know SDKMAN, it's a little tool, it's a command-line tool that allows you to install different SDKs. For example, Java, but it can be also other tools like Gradle or Maven, or there are a lot of SDKs out there. So what you can, for example, do is do a listing of all the Java versions that are out there, and so I'll grab for Graal in this case, and then we'll list out all the available SDKs that are out there, and then you can run a SDKI or install, and then say I want Java, and then the specific version that you want. Well, it will download it, it will set everything up, it will configure your environment, and it's ready to go. Well, excellent. We can do the same thing for Maven in this example. We're going to install Maven 3.88, just because, and it's all ready to go. Excellent. This works fine on both Linux and macOS. But if you want to do this on Windows, you have to have either a SIG-Win Windows or do it on WSL or whatever. It's quite hard. Anyways, a little bit of background information. I've been working for TenneT for the last 6 years as a consultant, and I've joined them in January this year. And TenneT is the high voltage grid operator in the Netherlands and part of Germany. So they maintain the high voltage network in the Netherlands. But it's not an IT company per se, because, well, they maintain the electricity grid. But more and more applications are developed internally within TenneT, but, well, it's not a big IT company. I work for the Department of Systems and Markets. Systems and Markets is the biggest department with the most Java developers within TenneT, and we have 85 Java developers. That's not much, especially when you compare it to the 10,000 people that are actually working within TenneT. And most of them are field workers, office workers, support staff, planners, and that kind of stuff. So we are just a small number of Java developers within a big company. Probably around maybe 100, 200 actual Java developers. We of course have different developers, like Apex developers or PSQL, that kind of stuff. So we do a lot of stuff. But, well, the IT department really wanted to standardize everything. So they gave everybody Windows laptops. Great. Luckily, we got a beefed up version of the Windows laptop and we get administrative rights, but still, it's a Windows laptop. So for the last 6 years, I've been working on Windows. Great. I do like SDKMAN. That doesn't really ring a bell for Windows. And I do like UI sometimes. So what I've decided to do is create a SDK Manager UI in JavaFX. Most of this is done in my spare time. And with 2 hackathons with my former employee and within TenneT, they gave me some time to actually invest in this tool. So if you want to play around with it, it's actually on GitHub. You can download the latest version. If you download it on Windows, you can open the zip file. There's a single application in there. If you start it up, it will ask you to install it, and then it's ready to go. Well, then you have a nice UI, which you can actually use, for example, to install a specific version of a Java version. And it will actually ask you to set up the environment variables that you need. So everything is ready to go. Now, of course, you want to use this specific version. And you can check out other SDKs as well. For example, Maven, install a specific version of Maven, set the environment variables for that one, set up another one, and it's ready to go. Once this is all done, unfortunately Windows still remains Windows. If you open command line prompt now, it won't work because it needs to reinitialize all the environment variables. So let's log out and log back in again. And we can actually check out the environment variables that are set. Within your user profile, you now have your Java home, Maven home, and the path correctly configured. So everything is ready to set up. So if we run Maven version on the command line, we have Maven 3.99. Great. If we run SDKMAN from the command line, we can actually change the version of Maven that we're going to use. In this case, 3.88. If we close it, run Maven version again, we have 3.88. So this is a small demo of the application that I've built. Of course, this works on Windows, but it also works on Linux or OS X. Because, well, it's JavaFX. Build once, test everywhere. So let's go back to the beginning. All the way back. So as a side note, this is my journey throughout getting a JavaFX application working within every operating system natively. So we're going to start out with something really simple. Not JavaFX, but something simple. The Hello World example. It's not special, but we need to start somewhere. I've created a Maven project. It's a simple Maven project. You could use Gradle if you want, but I wanted to learn native images and JavaFX and not something new, so I knew Maven, so this is what I choose. Let's create a Hello World class, and if we run it, it says Hello World. Great, we now have a nice application. But we want to package our application and get it to the clients or the customers or in this case the other developers that want to use my Hello World application. So what options do we have? Well, first off, we can just create a fat jar. That's easy. It's easy for the developers. It's just a Maven plugin that you can run, so no special tools needed. However, the people that are running the fat jar needs to set up the GRE or a JDK or well, GRE is good enough. So this is usually a step too far for most unfamiliar users. There's something else that we can use. We can use JPackage. JPackage is a tool that allows you to wrap your fat jar into a nice application. So you have a nice installer and that's specifically tailored for your operating system. So it's a simple command line tool and you get a decent application out of it. It's also easy for the developer. It comes with JDK 14, so it's a long time ago that it was introduced. And it supports every operating system and you get a nice installer out of it. So that's great. However, it depends on your operating system on what the experience is. If you, well, it's just drag and drop within OS X, but on Linux it's a command line thingy and Windows you get different things. So, well, it's nice, but not really what I want. Then we can use JDeploy. JDeploy is a little bit like JPackage, but then on steroids. JPackage actually creates a release page on GitHub, for example, which allows the user to download an installer. And if you download an installer, it will look like something like this on OS X. And it will allow you to also auto-update your application. So it wraps your application into a JDeploy application. And when it starts up, it will check out if there are new versions on GitHub, for example. So this is really nice. It has GitHub release support. It has the auto-updater function. And if you use Apple, if you don't know if everybody uses Apple, but if you build an application on your machine, ship it to another machine, Apple will say, hey, this application was made on a different device. I do not know this developer. Are you really sure you want to execute this thing and you have security settings and allow the application? It's really annoying. And JDeploy will actually sign that application with a valid Apple developer certificate, so that's quite nice. Unfortunately, it's signed with the JDeploy certificate. Sorry, application is a JDeploy application. But for the most users, it's good enough. And it's not really meant for command line applications. Speaking of command line applications, I think JBang needs a shout out here. JBang is a command line tool that you can install with a single line in either Bash or PowerShell, for example. And then you can use, in this case, JBang JReleaser to download JReleaser and including all the necessary packages in order to run that application. So you publish to a catalog and then a user can easily run your application. So this is quite handy for handling user environment because everything is set up correctly. It can run a GUI application or can a command line application. unfortunately is not really an application, because you have to always run a JBang in front of your application. So, but could be. Option number 4, GraalVM. I hope everybody knows by now what GraalVM is, but to make it short, it is a JDK with additional features, like enabling to create native images, so a executable for a specific environment. So this is great for both GUI applications and command line applications. There is no Java required for the user because it's all baked into the application itself. So the application itself has a native app experience. It behaves like a native application, and it's also a lot faster than the other options. Because if I start up my SDKMAN, it will actually run within 500 milliseconds. And if I run a fat jar, for example, it takes around 2 seconds in order to start it up. And with JDeploy, it's even more because, well, more stuff is bundled and it's going to check online and that kind of stuff. So this is a time saver if you on the command line doing things and just want to switch between a JDK, for example. Unfortunately, it has no installer. Although you saw in the demo application that I had, or the demo that I did, I had a installation step, but that's something that I created manually myself. So you can create one for yourself, but well, it's quite complex. And speaking about complex, let's find out how complex this is. So we're going to create our native hello world. That's quite easy. There is an excellent guide online on the GraalVM website that actually tells you how to set up everything on different operating systems and how to create a native image from your Maven or Gradle project. So you can choose which build tool you want to use. So we're going to follow this guide and apply it to our Maven project that we just created. So I'm going to use the main class quite often, so I will wrap it in a property so that I can refer to it quite easily. And then I'm going to copy paste the native profile from the guide. It's just there, and well, just copy pasted it. So we have now a native profile with a native Maven plugin installation, and it will run on the package phase. Well, this is actually all that we're going to need for our Hello World example. So if I run a Maven package with the profile native and let it run for a while, because it needs to figure out everything in our application, it will try to find code that is used and isn't used. And if code isn't used, it won't package it in your application. So in a Hello World application is quite small. It's around 12 megabytes or something like that. Still quite huge for a Hello World, but it still has a lot of things in it. So we now have a native image, so a native application. And if I start it up, I get a Hello World. This is now running entirely without a JDK or JRE. It's all baked in our native application. So if we run this on Windows then, well, let's go to our Windows environment. And there's also an excellent guide on the same GraalVM website that tells you how to install everything you need in order to get this working on Windows. You need Visual Studio Code with a lot of GCC plugins and that kind of stuff. So this is a big download. It's around 10 gigabytes or so. So you need quite a lot to make this work on Windows. But once you're done with the tutorial, and it's going to take you a while, you have a nice little additional command line prompt, the developer command line prompt, which sets up everything that's needed for the environment in order to run those GCC stuff in Windows. So in this command prompt, I can run again the Maven package with bnative, didn't change anything with our application. And if I run this, we get the same result that we just had on Linux. It will try to figure out everything that is needed. And by the way, this is sped up a little bit. So in real life, it's quite slow. Not this slow as what it says here, because this is on a virtual machine that's somehow eating 100% CPU just because it can. I don't know why, but it should build in around 20 seconds or so on a normal machine. But then again, we have an executable that we can just run. So we now have the same code on both Windows and Linux, and OS X if you want. So let's make it a little bit more complex, shall we? Let's add in reflection. Reflection is probably the root of all evil within GraalVM, so let's do that. And this is not just because I want to, but JavaFX is using a lot of reflection under the hood. So this is something we're going to run into a little bit later on. So we're going to create a greeter interface, which get the greeting, and we're going to have two implementations for that. A native greeter, which says innovation thrives in the native layer, and the world greeter, which says hello world. Well, great. Now we're going to load that greeter class with reflection. So we're going to load this class based on the argument that our application is getting. Don't do this in production, but for a demo application, this is excellent. So if you run the application with world, you get the world greeter. If you run it with native, it gets the native greeter, and it will print out the greeting. Great. So we're going to add the world argument to our application, and if we run the application again, we get a hello world. Yay. If we run a Maven package again, we have a nice build, but what will happen if I start the application with the world argument, for example? It will fail. It will fail miserably because it can't find the class. And why can't it find the class? Because GraalVM has figured out every class that is needed for your application, but it can't figure out that it was loaded dynamically, so it didn't include it in the application that has been packaged. So in order to fix this, you can actually create a JSON file. It's called the reflect JSON, reflect config.json. And here you can define which classes needs to be added to GraalVM in order to make GraalVM load those classes for you. However, I am quite a lazy developer, and I do not want to list all those things manually, especially when I'm going to use a framework that I do not use. So there luckily is a solution for that, and that's also on the GraalVM cookbook that we showed before, and that's in order to create an agent. An agent is a process that I will attach to your application. For example, we're going to start our application with Maven, so we can do that with the execute plugin. So we're going to attach the agent to this. I'm going to change the exec Maven plugin a little bit so it takes my program argument. And then I'm going to change the Maven plugin of the native Maven plugin a little bit. So we're going to say that we want to enable extensions, and in the configuration for the agent, I want the agent to be enabled. Now I can start the agent on the command line with a big argument, because we need to have the profile native, because the stuff is in the native profile. We want to enable the agent, we want to compile our application, we want to run our application, and we have, for example, the native argument that we want to run. So if we run this, we have in our target folder a native agent output with a reflect config JSON, which includes my native greeter class. Great. Let's run our agent again, this time with the world argument. What will happen now, do you think? What do you hope? If we run it, we now get the world greeter in our reflect JSON. Where did my native greeter go? It actually will override everything that is in the target folder, so that's a bit annoying. So let's fix that. And we're going to also fix the location where those files are outputted, because they are outputted into the target folder, and the target folder is not a folder that you normally want to check into Git, for example. So we want to have it somewhere else outside of the target folder. So let's say to the agent that we want the configuration there to be in our resources meta-inf native image folder. And we want to say to the agent that it has a config merge there. So it will actually merge those two configurations. So if you run it twice, it will actually not override, but merge those results. So if I run the agent twice again, I'll get a nice merged output. So now everything is there for me. And now when I build this and run those arguments with world and native, both will work just fine. So let's move on to JavaFX. Well, in order to get a little bit started in JavaFX, I really like to see what I'm doing. I'm not really like to code a UI. And there's a scene builder, currently maintained by GlueOne, which is just a what you see is what you get editor. Fine for my example and fine for my goals. So let's download it and start it up. And let's create an empty application. We're going to create our greeter application here. So first thing we need to do is get an anchor pane, for example, in there. And on the right side, you can see a lot of properties that you can edit. And well, actually what you edit is what you see also. So that's quite nice. So we change the width and we change the height. And then we're going to add a button for the greeter function. So drag and drop it. And we're going to change the property. We want to say greet me as text. And we want actually a function to be called when you click on the button. So let's scroll down to the on action. Let's call it greet me click. And where's that greet me click being called on? That's being called on the controller class. And that controller class is actually what we have created here. You have to create that class by yourself, but we have two functions here. The greet me click, that's going to be implemented later. And we're going to set the greeter so we can actually use that greeter method like before. So we're now using JavaFX. So we're going to add a lot of dependencies here. So we're going to add the JavaFX base, graphics, controls, and FMXML. You could do without FMXML, but then you don't have the what you see is what you get editor. Then you have to program everything out. You could do that. It's a bit like Swing, but on steroids. But some people like it. I like simplicity. Then we're going to implement our controller class here. So the greet me click, if you click on it, it will throw a alert box with the greeter. And we're going to create a start function that we can actually load that FMXML file and give it to the FMXML loader. And from that FMXML loader, we can get the controller. This is this class. And then we're going to show this this stage, so this application. But JavaFX really wants to have modules. It can't do without modules. So let's create a module for this. Let's call it JavaFX presentation. And we're going to open up our example to FMXML and to graphics, because there are reflections being called into our application, into our own controller class. So we're going to open up that for reflection. Then we're going to change our main application because, well, it's now a JavaFX application. So we're going to extend application. And we're going to remove that main method that we had before. And we're going to create a start method, override the start method in there. And we're going to call the start function on the main controller and give the greeter to that controller. So if the user clicks on the button, it should show it. So if we run this from IntelliJ, we get a bunch of errors, ignore them. And we got a nice little dialog. And if you click on it, you get a alert pop-up with the hello world message. So next up, let's make this native then. What can possibly go wrong? We have everything configured, right? We just can run our agents to get all the reflection information that we want. And let's go. And it fails. And it fails miserably because the GraalVM that I've downloaded doesn't include the JavaFX packages or JavaFX modules. Well, I can download those modules and JLink them to that JDK. Then there are some other stuff that still doesn't work. So unfortunately, I need to switch to a different JDK. And here comes GlueOne again, because GlueOne has a JDK already patched up with JavaFX and with the GraalVM built-in inside of it. Unfortunately, they're lagging a little bit behind. They're lagging behind on JavaFX version and on Java version as well. So Hopefully they will eventually update to the latest version. There is a 23 early access build, but it's not available in SDKMAN because SDKMAN always wants to have final versions in there and not release candidates that can update anytime. So what I'm going to do is just use the Java 17 version. There's nothing really there in Java 18 to 24 that I really want in my SDKMAN, so this is fine for me. So I'm going to install the GlueOn version of JavaFX 22 with JDK 17 and set that as the JDK that I want to use. But then I can remove a lot of stuff from my XML file and change it a little bit. Because if I want to run a JavaFX application from Maven, I need to add the OpenJFX Maven plugin. That will allow me to run a JavaFX plugin of an application just from the Maven command. And that's actually also what is being used by the GlueOn Maven plugin. So GlueOn has a Maven plugin that will actually set up everything you need in order to get JavaFX running. Because just adding those modules isn't enough for JavaFX. You will need a lot of things that are specific to an operating system. On Windows you need a lot of DLL files. On Unix you need a lot of SO files. On Mac as well. And that is also being downloaded by the GlueOnFX Maven plugin. So that's quite nice. They will download everything that I need. And that's called Substrate. So if you run into Substrate somewhere, this is what it does. And this is all the configuration that we're going to need. We no longer need our Maven native profile again, so just a plugin that we're going to run. So we can use the GlueOnFX run with, for example, the native argument in order to run our application. So if we run this, I'll get a dialog, and if I click on it, I'll get a nice pop-up. Great. So it runs. But we can also use run agent in order to run that agent that we had previously before. So if I run this, I will get all the information in the metainf native image folder by default, so that's quite nice. And it will spit out a lot of things. Also, JavaFX is using a lot of JNI under the hood. So that's also figured out everything that's needed there, so it's going to spit out everything needed. And unfortunately, due to a bug in the I think it's the GlueOnFX Maven plugin, we need to add the main function that's already in the application. That just says launch. It's the same implementation as in application. But hey, it needs it in this specific class. If I don't specify it here, it will complain that there's no main. And now I can just call Maven compile GlueOnFX build. And when I run this, it's going to take a little bit longer because, well, it's downloading a lot of stuff. But in my target folder, I have a JavaFX presentation again. And if I run that, it will just open the application and, well, it just works. Actually, if I do this on Windows, it works. And if I do this on macOS, it works. So we now have a JavaFX application that we can use cross-platform. Great. Let's make it more complex, shall we? Let's add a download. Let's download a file from the internet. Let's do something with cryptography. Jesus, that's a complex word as well. So we're going to just download my README from the GitHub page. There's nothing special about that. And the download function just gathers that input data from that stream. And, well, it just goes to the void, but hey. If we run our application again with the agent, we now can see that we have some crypto providers in our reflect.json. That's what is expected because it's an HTTPS connection. However, if I run this agent again on OS X, I will get this, a Apple security Apple provider. Guess what? That's not available on Linux and Windows. So GraalVM doesn't like this. This is a simple example, but there are some worse examples in Windows later on. But this means that we no longer can use our meta-inf native image gathering in every single operating system. We have to run this on every operating system in order to get the correct reflection for the specific target. So how we can do that? Unfortunately, we have to create 3 folders for Linux, OS X, and Windows. And we can actually use the Maven profiles, which can actually activate based on the operating system you have. So the first one will activate if you have a Mac OS X, and the second one will activate if you're on Windows, for example. And here I can just define a property, native image folder name, and then hopefully pass it to our GraalVM plugin, but unfortunately that doesn't work. The GraalVM plugin only likes to read stuff from the normal native image folder and nothing else, so you can't change that. There is a way around that. We can use the Maven resource plugin to just copy those files into that native image folder. It's a bit of a hacky, but this is just going to work fine. That also means if you run the agent, it will output to the native image folder. Then you have to manually copy it to the correct folder of the correct operating system in order to get this to work. So there's some manual steps involved here, but it's only when you generate those agent bindings. So let's add some more operating specifics, shall we? Because Windows is a little bit special. In order to do that, I've split up my application into a multi-module application. So we first had just the application, but now we have an API, we have an app, we have Unix, and we have Windows. I've bundled both Linux and Unix, both OS, Mac and Linux here as Unix, because they behave the same. And I moved everything that we had in the application folder to the app module. So just copy paste. And in our demo API, we're gonna create a OS worker. And of course, we're gonna add a module info because we're using modules now. And this module is called demo.api. And our interface, we're gonna implement that in the Unix module. Just simple getting that from the environment. Also a module, this module is called demo.impl. And in Windows, we need to do something more. We just can't get the environment information from the environment because that depends on which command prompt you have actually started the application from. So we need to dig into the registry in order to get the correct values from, in order to get the environment variables. So we're going to use a JNA platform dependency in order to get that working. So this is why Windows is a little bit special. In order to get this working, it's quite simple. We're going to just add a dependency to our POM, namely the demo.api. And we're going to use the same profiles that we had before in order to activate specifically on which operating system you want in order to include the correct dependency. So on Mac, we're going to include the Unix version, on OS X the same, and on Windows, we're going to add the dependency for Windows. So this is a nice little trick to get the correct dependencies only bundled with your application that you're actually going to need. And of course, we're going to add those demo APIs modules to our module for our application, and we're ready to go. We now can say OS worker is new OS worker impl, and based on the operating system that you're running on, it gets the either Unix version or the Linux version. And then you can just call that OS worker with the things you need. So let's switch gears to the SDKMAN UI then, because we want to create a SDKMAN UI for that. So let's fast forward a little bit and let's create this UI. And after a few clicks, we have a nice little UI that we can actually use and start to release. So we're now a little bit further in our project. and we can start actually releasing our application. So in order to release our application, I do not want to do this every time manually, so I want to automate this. And in order to automate this, I'll be using JReleaser. It's created in Java, so that's also nice. But it can also be used to release any kind of application. If you have a Go application or an NPM application, you can release it with that. You can even publish stuff to the Maven Central if you need to. It's an excellent tool. So in order to get that working, we need a JReleaser YAML and gonna define everything that in there that's gonna need. For now, the most interesting part is that we are releasing to GitHub. We want to create a changelog. We want to hide some contributors like GitHub itself because, well, you commit the version and you don't want that version to be in the release note of the next version, that kind of stuff. But the most important part is the distributions. And here you can see that we have 4 distributions. But how do we get those 4 distributions then? We will actually use the GitHub Actions in order to do that. So we have a assemble native that is a matrix pipeline. So it will fan out onto, in this case, 4 different machines. And based on that machine, we get the correct JDK architecture. So you can build a x86 binary on the latest version of Mac because, well, Mac has some translation in there. That kind of works, but I wanted to use the actual x86 machine in order to create x86 bytecode. So that's why I have the OS X 13, because that's the latest version that still supports x86. So if you look at GitHub, we'll do some pre-checks and then we'll fan out into those 4 different build machines. And then it will release the early access in this case, and there is the JReleaser that will bundle everything and will publish the stuff to GitHub. So in our pipeline, we have a little bit of additional steps that we're gonna need. We just can't call Maven build because, well, we did everything ourselves on both Windows and on Linux. So on Windows, we're gonna need the MS Build stuff that's in Visual Studio Code. We need the VS Code shell. But on on Linux, we're just gonna install some dependencies, and on OS X, we're gonna use the Xcode in order to make everything work. So this is the setup stuff for every operating system. So you can have one single pipeline, and then later on do the actual build. So unfortunately, every time I build my application, I'm probably gonna kill a puppy because I'm doing a Maven install. Maven install is not very nice, but in this case I need to, because later on I'm gonna call the GraalVM FX build specifically on the UI module, and Maven doesn't really know which other modules there are at that point, so it just fails if I don't install it first. So it should be fixed in Maven 4, but unfortunately I'm still on 3.88 because of the GraalVM FX stuff. And then I'm just gonna assemble a zip file with the assembly plugin and upload the package. So that package is available for the next step in the pipeline in order to gather everything up and make a nice release early access page on GitHub. And this is the same process for an actual release. Only difference is that the early access release is then replaced with an actual version number. JReleaser deserves its own talk by itself, and actually Martin Mulders and Tom Cools did that last year on DevOps. So highly recommend if you want to learn more about JReleaser, go watch them. Or watch the founder, Andreas Amarai, on releasing at the speed of light from his JFall talk in 2021. Not really that much fundamentally has changed since then, but it gives you a nice overview on what's possible. And with that, I would like to thank you. You can download the SDKMAN from GitHub. You can find me on Blue Sky. And this is the link to the slides. And with that, if there are any questions, please come on up. And with that, I'd like to thank you. If there are any questions, you can also pop them right here. Let me summarize. The Graal native doesn't support, or the question is, does Graal native support Windows? Yes, it supports native, but not for Windows. That's where GlueOne comes in with their JDK that supports all operating systems with JavaFX. So the GlueOne JDK is just the Graal JDK with JavaFX plugged on. And working on every operating system.
Working on everything. Okay.
Yeah, so that's include Windows. Yeah. 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 So the question was, does the GlueOneFX Maven plugin works on other JDKs? The answer to that is no. First of all, the GlueOneFX plugin uses the GraalVM, so you have to have a specific GraalVM version. However, if you would add JavaFX on top of the GraalVM, it should work. However, it's highly coupled to the specific version that they are aiming, and there are changes within the GraalVM that are no longer supported with command line arguments that they are using, so it will break. But if you use the same version, they really targeted their specific version. Yeah, yeah. They didn't change anything to the GraalVM itself. They just bundled it, but it's a specific version of the GraalVM, and there are changes within.
Try to go to like a newer version.
It will break. It will break if you go to a new version.
Probably break,
Yeah. Well, I'll give you 90% chance that it will break.
just want to be aware. Try to do those things.
Yeah. There is a way to get this all working within the GraalVM. Somebody has made a blog post about it. It's quite long, it's quite tedious, but you get it to work. But then you have to get that substrate, those DLL files, that SO files, the specific things that you're going to need on every operating. You have to manually gather those, set them in the correct position. So that's quite tedious. That's why I use the GlueOneFX.
Now I see why you back leveled.
Yeah.
Was it you had to use 7? I see
17. Yeah, I'm using 17. Yeah. Yeah. Yeah, and like I said, this is a spare time project. I do like to learn new things, but there's a point that I say, okay, I just want to make this work. How much smaller is the final project?
In terms of memory, RAM utilization.
That's a good question. I didn't look into the RAM utilization itself because it's a small application. It doesn't really use that much RAM, but well. And it's also running on a developer machine. It's not consuming a lot. So for my use case, it's not really relevant to optimize on RAM, for example. But GraalVM, the most important part of GraalVM is that it won't allocate everything in front. If you start up a Java application, you will define a minimum heap size, and it will always take that minimum. GraalVM will actually shrink down to what actually is necessary. So if you're only going to need 30 megabytes of heap, then a GraalVM native image will only use 30 megabytes. And if you use the minimum heap, probably it will be around 180 megabytes or so. You just want to be safe, or even bigger. That's the most important part of the GraalVM. That will immediately give free those memory that it doesn't really need. And with that being said, thank you, and enjoy the rest of the conference.